regards to lectures. I'll take all of them first, and you can be specific. This slide or that slide, or I didn't get that, or this, whatever that is. So, fire away.
There was a bit said about elasticity in the lecture.
Uh-huh.
We will cover it in the next lecture. Already discussed upon it.
Yeah.
And I didn't quite get the elasticity bit for the problem that we're going to discuss.
So, didn't quite understand the elasticity concept.
You mentioned something to do with log and elasticity, I think.
Okay, I'll talk a little bit about the elasticity concept and what that really means and how is it related to the demand function. And I'll give you a graphical overview that's not in the lecture, okay? But it's related to the math. So I just want to give you a slightly different perspective on that elasticity. So I can do that. What else is there? Yeah, Lisa?
Yeah, if we could go through just a price effect and volume effect, just quickly, just a little recap on that.
Price effect plus volume effect. We can certainly do that. What else? Yeah.
So here at the end it says, what is a marginal analysis? So I don't know if you really covered exactly what that means.
Okay. Marginal analysis. Okay, the meaning of it. Yeah, I can cover that. I can give you a perspective on it. Okay. Any other things? Yeah.
Like the PowerPoint also mentioned the learner index, and and we really just rush through this. Like maybe he will go through it in the next lecture, but
yeah. Learner index. Yeah, good. Okay, the more questions you have, the better it is, and every class will have slightly different questions, so I can cover slightly different things about the lecture when we go to this part of reviewing of the lecture. Let's start with this idea of the elasticity concept. I want to give you a slight different perspective on it. 1. Elasticity. Well, let's take a demand function. Let's take an easy one. And this is quantity, this is price. Let's define elasticity in words first. Elasticity. Anyone can tell me what elasticity is? Dan? In words.
It measures how much your price changes for a relative, or how relatively much price changes compared to a relative change in quantity.
Yeah, or the other way around, really. It measures the change in quantity, or how responsive is quantity changes to price changes. So if I change the price, so if I'm moving around the price, how responsive is my quantity, right? So this is sort of like the informal definition. So informal, but very useful, is to say that elasticity is a measure of the responsiveness of quantity with an increase in price. Okay? That's what that elasticity is, informal, okay? When you increase the price, what happens to the quantity? Decreases by purely how the demand is organized. It's a law of demand, which means that this elasticity will always be a negative measure, okay? Because quantity will decrease when price increases, i.e., this is the law of demand. This measure will be what? Negative. Now, let's be a bit more formal for the case of a linear demand. Let's be a bit more formal. Let's just call it formal. Formally, how could I define this concept of elasticity?
Change in price of change in demand. Proportional.
Thanks? Almost there.
Yeah, like the change in quantity, like the proportional change in quantity, proportional to the change in price.
A percentage change in quantity due to a 1% change in price. So formally is the elasticity gives us the percentage decrease, hence the negative, in quantity for a 1% increase in price. That's what it really gives us. It gives us this percentage change in quantity for a percentage change in price. So if the elasticity is equal to -3, what does it tell you?
Inelastic.
What about in words given this definition? If you want to say something more, what is it? What is that giving you?
Demand is inelastic.
You could say that demand is inelastic. I don't want to get to that definition of elasticity and elasticity for now. I just want to get to this, just really reading this -3. What does that -3 tell you? Yeah, Dan?
Price increases by 1%, then demand will decrease by 3%.
Exactly. The minus says that the demand will decrease by 3%. So if the price goes up by 1%, the demand will decrease by 3%. So for example, if at this point price was equal to 100 and quantity was equal to 100, if you increase price by 1% to 101, price prime goes to 101, what is your guess? What will happen to the quantity? If the elasticity at this point is -3. Anyone can tell me what's going to be your guess about Q?
So it would be 3% less.
3% less. So if it's 100 and you do 3% less, it should be 97. Yeah, easy. That's the meaning of elasticity when you look at it purely on this percentage increase and decrease perspective. Now, Madhur, what's the formula for revenue? Revenue.
The quantity sold into
Yeah.
the price of that.
Price times quantity. Okay. So this revenue depends on the price you're selling stuff and on the quantity that you're selling stuff. So it depends on two different things. Okay. But the price affects the quantity. Okay. They're affecting one another. Okay? So when you increase price by 1%, what's happening to the quantity? It is decreasing by 3% in this case. So what can you say about what's going to happen to the revenue at that particular point? What's going to happen to your overall revenue if price goes up plus 1% and quantity goes down 3%? What's going to happen to your revenue? Louisa?
It's gonna go. Well, I don't know. How can you tell that?
How can you tell that? It's a good question.
The revenue will decrease.
The revenue will have to decrease. But the question is, how can you tell that? It's very easy how you can tell that. The way that you can think about this going up by 1% is the same thing as thinking of P times 1.01. If you multiply the original price by 1.01, that is going to be your new price. This is going to be your P prime. If you want to decrease Q by 3%, you can do that by thinking of it as Q times 0.97. That would decrease Q by exactly 3%. This thing here is going to be your Q prime. But what do you know about 1.01 and 0.97? So you're going to have 1.01 times 0.97 times the original P times Q. What do you know about this? Lower than 1 or greater than 1? Lower than 1. So you know how Darlington was kind of jumping the gun here and says, this demand is elastic, right? What did he really mean? Elastic really meant that if you raise the price at this point, your revenues are going to go down. Why? Because the percentage decrease in quantity is going to be higher than the percentage increase in price, and your revenues are going to go down. Right? So elastic part of the demand means you raise the price, your revenue are going to go down. Okay, let's take another case. So I can talk about elasticity at starting from 0 and going all the way to minus infinity. So I can talk about 1 here, and all this area here is going to be minus 1. All this area here is going to be inelastic. Dorothea, do you want to explain that? What is that meaning of that inelastic over there? Why is it inelastic?
That changes very little for changing price.
It changes by less, right? By proportion less. So if it's 0.5, when you increase price by 1%, quantity only decreases by 0.5. So overall, your revenue is increasing, right? Overall, your revenue is increasing. So this bit here is what we call elastic. And this bit here is what we're going to call as unit elastic. So at that particular point, your revenues should not be changing by that particular change over there. Okay? So let's say that you have 0 cost. Okay? You're a monopolist and you have 0 cost. Okay? And let's say that you are in this part of the demand for whatever reason. Okay? Let's say that you're setting a price such that elasticity is here. Okay? That's where elasticity is. If you are on an elastic part of the demand and you only care about maximizing revenue, what should you do? If you increase price, what will happen to your revenue? Decrease. By the same token, if you decrease price, what should happen to your revenue? Increase. So if you're a monopolist and you're on the elastic part of the demand and you only care about maximizing sales, you should decrease your price. Okay? What should you do if you are on the inelastic part? You should go to unit elastic. Okay? So it's the unit elasticity over there where you're going to maximize your revenues. I will explain that in a second by making use of a graph. So let's make use of a graph. Let's take any demand function. Doesn't matter how it looks like. Let's make it a little bit like this. Let me define elasticity as percentage change in quantity over percentage change in price. So this bit here is changing quantity over quantity, so this can be thought of as percentage change, okay, of quantity. This bit here can be thought of as percentage change of price. So if I want the elasticity at this particular point here, let's call this point 1, and let's ask ourselves, what is the elasticity at point 1? Well, it is very simple. I'm going to need a few ingredients. I'm going to need P1 and I'm going to need Q1. And then I'm going to ask myself the question that the elasticity must be equal to change in Q over Q1 over change in P over P1. Where, of course, what's going to happen here is that I'm going to raise price P1 by a little bit, right, by 1%. And I want to know what's happening to the, what's happening to the overall stuff. But I could rewrite this as P1 over Q1 times delta Q over delta P. Right, so I could look at, little tiny deviations away from here, or just go to another point here. And look at this idea of delta Q over delta P. What do I know about this, delta Q over delta P? If I take any point, it doesn't matter whether it's here or here or here, and I move from point 1 to any of this point, what do I know about this delta Q over delta P? Anyone can tell me what do I know about that delta Q over delta P? What is that going to be?
Negative.
It's going to be negative for sure, because delta Q is going to be the opposite sign of delta P. So if delta P is positive, delta Q is going to be negative. So absolutely. This thing here is definitely going to be negative. It doesn't matter which one you pick. But it's also going to be, for example, let's say I pick this point here. It's going to be the difference between these 2 points. So it's going to be this delta P here, and this is going to be delta Q. Agree? Imagine that you took these other 2 points. Let's go with a different color. This is going to be delta, oops, didn't want that. This is going to be delta P. This is going to be delta Q. What do you know about that ratio of delta P over delta Q? What do you know about the ratio of delta P over delta Q? What is it? Say it again?
Constant.
It's constant. Why is it constant?
Slope of the curve.
Is the slope of the line. That's where your pre-sessional courses, the stuff that we did, will come in handy.
You mean the gradient?
The gradient or the slope, same name. So delta P over delta Q is simply the slope of the line. Is that a positive slope or is that a negative slope? Negative, because it's sloping downwards. That's why Levisa was saying that should be negative, right? Because that's a negative slope. So what is this delta Q over delta P then? It's simply 1 over the slope, because it's the opposite, right? So this delta P is negative. It's also constant, and it's also 1 over slope. Okay, 1 over slope. So whenever you calculate an elasticity, you're kind of already done with this part here. This is just going to be 1 over the slope. Okay. So let's do this bit here. Let's focus on this bit here. What about this? What can I say about this?
Proportional change.
It's not quite a proportional change, because you don't have changes, you should have deltas there, darling. If you don't have deltas, you have no changes there.
But how can you figure out, you've given two
Yeah.
points?
Now you don't need 2 points, that's just P1 and Q1. Where the 2 points come in handy is when you do this delta Q, right? What is this delta Q? Q2 minus Q1. That's when you need the second point, right? But for this part, you don't need a second point. You only need the price and the quantity that you have over there. So what is P1 over Q1? It's just a ratio of prices to quantity. That's all it is. Agree? Sounds simple, right? Now, here's a graphical way that you can view it. If you do a ray from the origin to the actual point, what will the slope of that ray be? Positive or negative? Positive, because it's going upwards, right? And what would be the actual value of that slope? I'm not looking for a number, I'm looking for an expression. P1 by Q1, right? If you look at this bit here, this height here is just P1. This height here is just Q1. Remember how we calculated the slopes? Rise over run. So it's P1 divided by Q1. So what is this? Let's put a name to this. This is the slope of the line from the origin to the point of interest. Agree? Okay. Varno?
Yes.
What happens to the slope as my point of interest gets very, very close to the y-axis intercept? What happens to that slope as it gets very, very close?
The slope will increase.
The slope will increase, right?
Yeah.
To what? As that slope gets close to being vertical, what will be the value of that slope?
If it become like if it's not exactly vertical.
Yeah.
Something less than y.
Something less than.
Because if
It's not going to be y, because remember the slope is going to be price over quantity. The quantity over there is going to be something very small to 0. If you divide something by something very small, very close to 0, what do you get? Something really big.
Oh yeah.
Divide something with something very small, you get something very big. Which means that this part of this gets very big, as you approach the y-intercept, because P over Q, this tends to 0, this tends to whatever number you have here, A, right? This tends to whatever A you have, and A over something that tends to 0, very close to 0, tends to infinity. Okay? So, if this slope here, if this 1 over Q is negative and constant, and this P1 over Q1 goes to infinity as I get closer to Y, what should be my demand here? Should it be elastic or inelastic? Elastic. It should be elastic, okay? Right? It should be the elastic part of that demand. And really at this point here, what is the elasticity? Minus infinity. Right? At that particular point, elasticity is really minus infinity. Make sense? Now, can you do the following exercise? See if you can think about it this way. What would be the elasticity at some point very close to here? See if you can do that on your own, okay? Do it on your own. If you're done, just give me a bit of a hint that you're kind of done.
Could you just repeat the question again?
The question is very simple. Imagine that I gave you a point here, A, and I'm asking you, what is the elasticity of A? I don't want an actual number, I just want a rough idea of what that elasticity will be. You have it? Okay. You have it? Yeah? Don't know. Maybe. Let me give another minute for everyone to think about it for a second. Okay, what answers do you have? Dorothea, what do you have?
I would think that it's close to 0.
I think that's close to 0. Do you all agree that it's going to be close to 0? Yeah, it should be something very close to 0. If you think about this, do a ray from the origin what's going to be the slope of this ray from the origin? Is going to be whatever the price is over there divided by whatever the quantity is over there. But the price over there is going to be very close to 0. The quantity is going to be relatively large. So here should be approximately 0. And what should the elasticity be exactly at this point here? 0. Exactly. And what should the elasticity be as you go from here to here? What should happen to the elasticity? It should go from minus infinity, and it should increase, strictly speaking, because it's going to get less negative, right? So the elasticity increases as you go down this line here, and it takes all possible values. So in a linear demand, it would be silly to say, oh, this demand is elastic, or this demand is inelastic, because every demand, depending on which point you are, could be inelastic, elastic, unit elastic. Okay? Now, remember, let's go to precessionals. One curve that I drew was this. One thing that I drew and when we were solving the monopolies problem was this. I gave you a demand function that looked like this, P, Q, and then right below here, I gave you something like P and marginal, or not marginal, but I call this revenue. Revenue as a function of P. Do you remember this? How was this graph looking like? You remember this? Gia? How was the graph looking like? Like a U-shaped thing, right? Yeah. It looked something like this. At here, you make 0 revenues. Then at here, you also make 0 revenues. And it kind of looked something like this. Agree? That's what it looked like. Do you remember this? You remember this, right? Let's draw like a point here at the peak of this. Should have drawn this slightly differently, but what do you know about revenue? What happens to revenue if you are on this section here? If you're on this section here and you increase price, what happens to revenue? Increase. Rev increases as P increases. What does that mean? Sorry, as P increases, yes. Sorry, you're decreasing P here, right? P is going down. This is the maximum P that you can get, and now P is coming down this point here, right? Made a mistake here. This should be Q, this should be Q, this should be P, okay? So if you're here, revenue increases as P decreases. Luvisa, what are you thinking there?
Yeah.
Yeah, makes sense?
Yeah.
Okay. I do want you to stop me, okay? I don't want to cover stuff. My goal in class is not to cover everything. Actually, I don't come with a plan of covering X, Y, Z. I come with a plan on what I'm going to cover over the whole week, right? But which class I cover that with, I don't really care. But I do want that discussion of like, I didn't get that. Let's do that. So this bit here, remember what we said about elasticity? If price increases and your revenue decreases, then this area here is going to be the elastic part of your demand. This is elastic. Elastic, which means all of this bit here is going to be elastic. So, what's happening to the revenue on this part here? You lower price, your revenue is decreasing. What part of the demand is that? Inelastic, of course. This bit here would be inelastic part. Because remember, we talked about this concept of elasticity. We talked about, remember when I introduced this concept of elasticity? I introduced it as a way to figure out what's happening to your revenues. Okay? That's what it was. So, if you think of it that way, hopefully this will give you a slightly different perspective of how to think of this elasticity. So let's try and summarize what we did. we motivated the concept of elasticity by figuring out the responsiveness of quantity as price changes. We looked at revenue, which is an important part of a monopolist, right? He wants to look at sales. And we were able to say things like, if the demand is elastic, that means that raising the price should lower your revenue. So what should you do? If you're in an elastic part, you should lower the price. So this graph here tells you exactly that. Tells you keep lowering the price, because if you keep lowering the price, my video stopped. So if you keep lowering the price, right, you will increase the profits, the revenue. You lower the price, revenue increases. What do you know about the elasticity right at this point here? What do you know about the elasticity right at this point here?
It's -1.
It's -1. Is the unit elasticity. It's the point where revenue shouldn't change if I change price by a little tiny amount. And quantity should change by exactly. So this bit here is the unit elastic point. So I'll conclude here this section of just elasticities and how to go about seeing elasticities in general.